In problem 21, we're asked to translate "I have worked all week, but I have not been paid" into symbolic form and then make a truth table. When you're translating it into symbolic form, you have to define what your symbols are going to mean. You have some choices. You can either make these statements in a positive fashion or a negative fashion. So I could put P, I worked all week, or P, I did not work all week. Q, I have been paid, or Q, I have not been paid. I tend, at least at the beginning, to just make these statements that we're writing down, that we're defining, to always be the positive version. And then I can use the not symbol if I need to here. So now, I have worked all week, that is P. But I have not been paid, that is not Q. And it seems as if what's being said here is that both things are happening, and so that seems to me to be an and. So we have P and not Q. Now we're going to make a truth table, put these in alphabetical order. When you have two statements in your truth table, the first one, by agreement, we're going to put true, true, false, false. The second one, true, false, true, false. We always do a two-statement truth table in that order, simply out of convenience. Notice it catches all four possible combinations of T and F. So we have TT, TF, FT, and FF. Now we need to build towards this statement. We have a P, but we don't have a not Q, so let's put in a not Q. And it's the opposite values of the Q column. So now we have a P and a not Q. The P is here and the not Q is here, so we're ready for a P and not Q. Now with and, the only way an and can be true is if both parts are true. So this is the only place where P and not Q are true, so that's true. The rest of these are going to be false because they have at least one false in them, and in fact this has two falses in them. So this is our final answer on the truth table. In problem 33, we got two parts, A and B, and we don't need a full-fledged truth table because we're just trying to figure out, given certain information about the simple statements P, Q, and R, can we figure out the truth of the compound statement? And we can do this a couple different ways, but let's do it by substitution. So we're taking this general statement and we're substituting in true or false. So this says not R. Well, R is true. We know that from the given. So not R is false. And P is true. Or Q is false. So false and true. If you have an and statement of two simple statements and one is false and one is true, the and is going to be false because the only way an and statement can be true is if both parts are true. So we have false or false, and that is the only way an or statement can be false. And so down at the bottom of this compound statement is the fact that it's a false statement given these conditions. Part B is the same kind of problem, but we have different initial conditions of our simple statements. And so let's do some substitution again. We have not R, but R is true, so not R is false. And we have P is false. Or Q is true. False and false is false. False or true is true because an or statement's true when any part of it is true. And so now this compound statement is true based on these given statements. Notice we could have done a big truth table for this, and then these two answers would have been part of the truth table. But here we're learning how to answer some questions without the full-fledged truth table. In problem 37, we're asked, is this and statement true or false? Well, an and statement can only be true if both parts are true. So if we check this one and it's true, and we check this statement and it's true, then true and true is true, and we're done. Any other possibility and it's false, and we're done. So we come over here and we get 15 on the left-hand side, we get 15 on the right-hand side. That is true. And then we have an AND statement. I'll use our symbol for AND. And then over here we have 9 equals 9, and that is true. So we have true and true, which is true. So 37 is a true statement. Problem 59, we're asked to translate some words into symbols, a compound statement into symbols, given some simple statements. Notice how these simple statements P, Q, R are in the positive form. They don't have a not in front of them. And notice the placement of the comma also. It says in problem 59, the heat is solar generated, comma. So I have the heat is solar generated, that's Q. And then comma, or. And I think that comma then separates the Q from the rest, and that's why I put parentheses around the rest. And so it says, or the house is owned by an engineer, that would be P, and then it says the car is not run by electric power, so that's not R. So this is my translation, and now I need to make a truth table for it. Now the truth table with 3 statements, P, Q, and R, I think should always start the same way. We're going to put P, Q, and that R in that order, and then we're going to fill in these 3 columns in the following manner. Do this always. So again, please, when you're using 3 statements, P, Q, and R, put the 3 statements in the order P, Q, and R. List them in the positive version if possible. Don't put nots in. And then for P, do 4 trues and 4 falses. Q, do 2 and 2, 2 and 2. And for R, go true, false, true, false, true, false, and alternate. This gives you all 8 possible combinations of 3 true and false things. One is all true, one is all false, and then several in between. Please do them in that order. Now, what do we need next? We need a plan. We're trying to work our way to this compound statement. But we have a P and a Q already, but we don't have a not R. So it seems as if a not R would be a thing we need. So we're going to take the opposite truth values. Now what do we need next? Well, we need a P and not R. And so let's put a place for P and not R. P is here, not R is here. But what makes an and true is a couple of trues. So let's look for a couple of trues. Here's a true in P and a true in not R, so that's true. Here's another one that's true. We have a true here and a true here. None of these can be true, so that means they're all false. And this is false, and this is false. So we had 2 truth results and 6 false results. And now it's time to do the final OR. So we're going to do a Q, OR, and then this thing we just did, P and not R. So Q is here, and P and not R is here, and we're going to combine them with an OR. Now as OR is true if any part is true. So what I like to do is look for false false, because that's going to be false. So here's a false false. Q and Q or P and not R. So both of these are false. That means the OR is going to be false. It looks like both of them are false here and here. So these are false. It looks like this one's true, this one's true, this one's true, this one's true, and this one's true. So the book has us, in what cases is this true? Probably the best answer is it's true when P, Q, R are all true. It's true when P and Q are true and R is false, and to list it that way. What the back of the book says, it's true in case 1, because this is case 1, and case 2, not true in 3, it's true in 4, and 5, and 6. These are the rows that have trues in them. The problem I have with that is we technically had a choice in how to set this up. And if we had set this chart up a little differently, we still would have had 5 truths, but they might have been in different places. And that gets very confusing, and the teachers get mixed up about what students are answering, and the students themselves get mixed up, and it's a problem. So I won't be asking you this kind of answer on an exam. I'll be asking for this truth table. That's what I'll be asking for. And I've asked you to set up P, Q, and R with no knots in them, and then we should not get quite as confused.